Now, 44th question. So that question involves addition of HOBr and addition of HBr in the presence of peroxide. Now, you know that in the presence of peroxide that follows a anti-Markovnikov rule. So that reaction intermediate is a radical. HOBr addition is follows Markovnikov rule. Here OH minus Br plus. Your oxygen is more alkylative. So that is also anti-addition. So it is a reaction intermediate. And NOBr, NO plus Br minus. It is also anti-addition, follows a Markovnikov rule. It is a reaction intermediate. Nitrosonium ion, cyclic nitrosonium ion. And here addition of NOCl. You know this one. It is a Tildens reagent. We discussed in class also. That addition also follows Markovnikov rule, and it is also anti-addition. The same nitrosonium ion is the reaction intermediate. Now next here Br plus Cn minus bromocyanogen. It is also follows Markovnikov rule. That is a cyclic bromonium ion is the reaction intermediate. That means here Cn minus attacks from backside, so it is also anti-addition. Next here iodinium chloride with this reagent. This addition also follows Markovnikov rule. That reaction intermediate is a cyclic iodinium ion. So in this case here next Cl minus attacks from the backside. That's it. So here another one new reagent here I am bringing. So that is thiocyanogen, SCN twice. So here two similar groups are added, but this addition follows anti-stereochemistry. Okay, that is also anti-addition. Next here phenyl chlorosulfide. So this addition also follows Markovnikov rule. Here PHS plus and Cl minus. So first of all here cyclic intermediate ion, and then Cl minus nucleophile attacks from the backside. We will get this compound that follows a trans addition. So all these reactions are the trans addition reactions. Now here another good question, that is 42nd question. So here you know this one, in alene there is no resonance, but here in ketene there is a resonance. Here in alene there is no pi-pi conjugation. In ketene there is a pi lone pair conjugation. This lone pair is in the plane of this pi bond. So that's why here resonance is possible. So for example here this is the pi bond, and this is the pi bond for this carbon and oxygen, and this carbon this is the pi bond. These two are perpendicular to each other. That means here this remaining lone pair is perpendicular to this pi bond. That means here parallel to adjacent pi bond. So these two are in the same plane. That means parallel each other. So resonance is possible. That's it. And you know that diazomethane resonance is also possible. In class we discussed that we wrote that different type of resonating structures for diazomethane. Generally we are saying the stability of the different resonant structures for diazomethane. So in diazomethane also there is a conjugation like this. And now here carbon dioxide. In the carbon dioxide also resonance is possible, and bond lengths also different. In chemical bonding we discussed that one. Of course in a academic textbook also this CO2 molecule is given in chemical bonding. So now next here phenyl anion and phenyl cation. In this case here this negative charge is not involved in conjugation. This pi bond, this positive charge is not involved in conjugation, because here these orbitals in the plane of the benzene. But here these pi bonds are parallel each other. So this is the resonance. This is only pi-pi resonance. So here negative charge is not involved in resonance, or positive charge is not involved in resonance. But in case of the benzyl carbocation or benzyl carbanion, resonance is possible. Okay. And next 45th question we discussed this one also. Oxidation, atmospheric oxidation on Grignard reagent. That is first of all peroxide is formed, an excess of oxygen that gives oxide, and this one on a hydrolysis will get the alcohol. For example here the small application phenyl bromide, and treating with magnesium will get the phenyl magnesium bromide. So followed by atmospheric oxidation and hydrolysis will get the phenol. So it is also one of the preparation method for the phenol. Now in 35th question, in SN1 reaction, in SN2 reaction, which of the following reactants gives the same product? Generally in SN1 reaction there is a reaction intermediate, that is carbocation, so there is a chance for the rearrangement, and in SN2 reaction, that is single step reaction, no chance for the rearrangement. So here for this one, in SN2 reaction there is a direct substitution, but in SN1 there is a first of all carbocation is formed, and here by the H minus shift we will get the stable carbocation, that is the tertiary, so nucleophile attacking, that is the product. Now these two products are different, but for the second case here, that SN1 SN2 substitution products are same. In third case, SN2 reaction, there is a direct substitution product. In SN1 reaction, first of all this carbocation is formed by the H minus migration, we will get the allyl stable carbocation, then nucleophile attacks, that this substitution product and this substitution products both are different. So this reactant gives a different products in SN1 and SN2 reactions. And this benzyl chloride that also involved in SN1 SN2 reactions and produce the same product also.